Chapter 1 is all about just the basics of geometry. So a really introductory level geometry stuff starting off here. The first section, 1.1, is all about finding and describing patterns. So we will be working on the first white sheet, I believe, in your notes packet. On the back, does that look right? Okay, sounds good. When you hear pattern, what do you think? So you can go ahead and write this down. A pattern is a group of numbers or objects in which all the members are related with each other by a specific rule. So you guys were saying it's something that happens repeatedly. There's repetition in a pattern. So once you establish the rule, that rule affects how each of the objects change in relation to the other. So patterns can be finite or infinite. Finite means there's definitely an ending. And infinite is when the pattern goes on and on and on forever. All right. So if the pattern ends, it's finite. If the pattern does not end, continues forever, it's infinite. I don't think there's a space for this in your notes. Oh, do you see where it says 2 types? Yeah. So jump down a couple lines, write 2 types. I think we'll fill in the rest as we go. All right, patterns are literally everywhere. As a class, can we brainstorm any patterns? Yes.
Traffic lights.
Traffic lights, they follow a pattern, right?
Yep.
Green, yellow, red. Green, yellow, red. Green, yellow, red. I like it. So you can try to list like 3. So I'll go with that one. Hold on, let's let somebody else out. Is there another hand? Yes.
The checkers design on the rallies?
Yeah, just a basic checkerboard design. Yes, that is absolutely correct. So yes, you can write it in words or you can draw it. So this one is like black, white, black, white, black, white. Yes. Ooh, that's a good one. The phases of the moon. Like it gets smaller, like you start with a full moon and then you have less moon, less moon, less moon, less moon, no moon. I think they call that a new moon. And then it gets bigger, 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 bigger. That is funny. I was just looking at when the next full moon was going to be over my lunch hour, which was last hour. So that's perfect. It's in September 13th. Next full moon. All right. Anyone else have any patterns? I said list 3, so those are the only ones I'm going to put on.
Does ABC count?
Yeah, sure. The way that our bells work here, right? The bell rings at 25 and 30. Doesn't ring again for an hour unless it's a lunch hour. 25, 30. Doesn't ring for an hour. The seasons. I thought you said Caesar. I'm like, salad? Like, I don't understand. The seasons. Yeah, we get the 4, the pattern continues. Summer, fall, winter, spring, summer, fall, winter, spring. Good. So patterns are everywhere. Some of them are easier to catch on to than others. And we are going to also think of these. These are more visual patterns, which we did have one when we drew the checkerboard. That's why that was a great example. You don't need to draw these or anything, but they're kind of cool, just noticing what is happening each time and how it's repeated to fit together as a whole unit. Okay? Why are patterns useful? I'm a planner. So you know why I like patterns?
It keeps everything organized.
Yeah.
Sucking up with organization.
Yeah, it can keep people organized. Or what were you going to say? Helps you remember. I like them because it helps me make predictions. If I notice, I'm a very logical person. If I notice what's happening and the same thing's happening over and over, I use that information to figure out what I think is going to happen next. So it works for organization, planning or making predictions. A lot of times, patterns will help you find an error if all of a sudden one number sticks out from all the rest of them. That's helpful too, so maybe finding errors. Lots of reasons that they're helpful. Or like just this traffic lights one. When you're driving, you're a lot safer if you remember the pattern, right? What comes after yellow? Red. So you better slow down because the red light's going to be there any second, okay? So again, organizing, planning, finding errors, being prepared for what's happening next. All reasons a pattern works. Now, I think I might have messed you up on your notes because I think what the notes we're going for were these two types, which is fine. Just fill these in where it says numbers, example, visuals, example. You'll be good to go. There are two types, finite, infinite. That's fine. You don't need to erase it. Leave it. Still works. Still holds true. But as far as this class, these are the two types they were going for. So we will look at both. We talked about both, which I really like. You can have patterns in your numbers. So like the bell schedule was a very clear number pattern. Here's another clear number pattern, 1, 2, 3, 4, 5. Or you can have visuals like the checkerboard or the stoplights or those honeycomb ones we were looking at. So there's a visual pattern. You can see you have a pentagon. Pentagon is a polygon with 5 sides. So 5 sides and then the little balls sort of just going up from one vertex to the other around the figure in a clockwise fashion. So here are the first two examples. The first thing I like to do is just sort of start with the first number and then just imagine ways to go to the next number. So here the number's getting smaller. For numbers to get smaller, it's typically subtraction or division. So I like to start with those two. If you subtract 3 from -2, you end up with -5. Subtract 3 again, you get -8. Subtract 3 again, you get -11. So I can assume the next number will be... -14. Good. But here we are just describing it first. So each term is decreased by 3 to determine the next term. And then we're filling in 2 more numbers. You guys have directions in yours, right? Yes. So it says describe the pattern in a complete sentence and then find the next 2 elements of the pattern. So yours is missing the -5 and the -8. So fill those in. And then in blue, those are the answers. So the first answer is to describe in a full sentence what's happening. Each term is decreasing by 3 to determine the next term. And then the next one would be -14, and the one after that would be -17. All right, so on the next one, we're looking at shapes. We have a triangle, a square, a pentagon. So each time, what's happening to the number of sides? It's going up by 1, right? Now, here's the trick. You're going to have to draw a figure with 6 sides and then a figure with 7 sides. I'll help you out. That's what they should look like. I'm not going to grade your notes. I mean, I might grade your notes based on, like, did you do it and did you highlight it? But I'm not going to go in there and be like, oh, the side on the heptagon isn't, I'm not going to grade it on your art ability. So I'll give you a few minutes to catch up with those. The biggest mistake I see on this section for students is just simply not reading the directions. If the directions say describe the pattern and complete the pattern, make sure you're doing both parts.
when it's like complete, we always do 2 more.
Mm-hmm.
Okay.
Usually, yeah. All right, number 3, the arrow is going to the right, the arrow is going to the bottom, the arrow is going to the left. Can you describe what's happening? Left, down. So yeah, here's a bit more. I know what you're trying to say, but here's a bit more of the math terminology. So the way the arrow points rotates 90 degrees clockwise each time. So 90 degrees is a right angle. It's just it's like a quarter turn. So it's turning a quarter turn. If you said a quarter turn, I would accept that. But the geometry term for that is a 90 degrees. Clockwise is the way a clock moves. So like if you're turning your car to the right, that's clockwise. Okay, so the arrow is going 90 degrees clockwise each time. I feel like a lot of people don't use clocks like that anymore. So it's hard to imagine clockwise, but I think you're turning your car to the right. So which way will the next arrow be facing? Up. There you go. And then turn it again, and you're going to the right. So the pattern repeats itself here. Every 4 arrows, it just starts over.
I like that movie. I like the movie.
Oh, I was like, what movie? Up. I have actually never seen that movie. I saw the first 3 minutes. It was so sad. I just, I don't know. All right. 1, 3, 6, 4. Sorry. I'm trying to do the math in my head. 1, 3, 6, 5, 15.
You said 5 or 10.
No, I said 4 because I was trying to think, well, how do you go from a 4 to a 10? So I was doing math in my head and saying it out loud instead of, I'm sorry. So how do you go from 1 to 3? How do you go from 3 to 6?
3.
How do you go from 6 to 10? 4, that's the part I said out loud. How do you go from 10 to 15? Okay, so you can see what are we doing each time? So we're adding a number, and that number is going up, okay? So the number added to the previous term increases by 1 each time, starting with 2. Another way to say that would be you're adding increasing integers. That's probably the word I would have chosen. Adding increasing integers starting with 2. So tell me where you start. Tell me how it changes each time. Tell me the operation. Sometimes we subtract increasing numbers. Sometimes we multiply by increasing numbers. So I need to see the word add. I need to see that it's increasing by 1. And I need to see that you started with 2. If your wording isn't exactly the same as mine, it's not the end of the world, but those are the pieces that I need. All right, what do you add then next? 6. So that would be a 21. And then we add a 7, which would be a 28. Perfect.